Okay. Good evening, all of you. So let us start our topic, and we were learning the Scala, that is a programming language. Later on, we will see some basic syntax, and if the time permits, then we will see some of the executions of these Scala programs. It is required for the practical number 2 because we require to run with certain kinds of basic syntaxes, which is from the Scala. So let us continue. I'm just sharing my screen and just tell me whether the screen is visible or not. Is my screen visible?
Yes, sir.
Okay. So basically here we will see the meaning of the tail recursion. So here we know the meaning of the recursion. So basically it is the one type of the function where we are calling our function into a function. So basically the code will look like this. I will just open one notepad to explain this particular code. So for example, we can see we have defined one function. So let me call this particular function as def function 1, and here you are passing a several number of parameters as we do in a Python or as we do in a normal programming languages. So it may be a parameter 1 and parameter 2. Okay, let us consider these particular parameters have defined along with their data types. So let me define it as like here the data type 1, as we have defined in last lecture, or we have studied this particular part in the last lecture, so that you can see a variable name and its respective data type is defined. The data type is defined using the colon, so that you can find out the relation between the respective data type and the respective parameter. Here we can also relate our function data type, that is a return type of that particular function, but it is not mandatory because we are free of writing the return statement, and also we are free of giving a semicolon. Means there are several kinds of concession is given while writing a particular program, and that particular thing is important. Means whenever you are writing a certain kind of program, if you are means it saves you some time for solving those particular syntactical errors. So this is a particular function, and now I will try to write down its body. So it is a statement 1, it is a statement 2, etc. And again I will call this particular function, that is function 1, along with the parameter a comma b. Okay, or I will be passing a certain kind of values, or I will be passing a certain kind of variable. So here what we are doing here, we are defining the function and we are calling this particular function inside that particular definition. This particular concept is known as the recursion. So in the case of recursion, you are supposed to write your function, or you are supposed to call your function inside the definition. Now how this particular problem is solved, you may feel like it will go into the infinity, but it is not like this. Basically there will be a certain kind of condition. Means for such program we have to write down a terminating condition, so that our output will stop somewhere. Otherwise definitely it will go on calling and calling, and we may not get the appropriate result. After some time, particularly you are working with a Spark or you are working with a Java, you will come out of that particular loop by not giving any kind of desired output. But if you are writing certain kind of program, you have to give a certain kind of desired output, so that we have to write down a certain kind of condition, and that particular condition will be written in the form of statements. So that we will see the example of the factorial program that is already given in our slide. So before that we will understand the structure. So whenever you are calling a function, inside the definition of the function we are calling it as a recursion, and this is a particular definition over there. Now how these particular functions are solved? So here you are supposed to evaluate the inner function first, so that a function 1 will be executed. Means for example here again you are calling function 1, the function is also calling function 1. So there will be hierarchy, like this is the first hierarchy, this is the second hierarchy, then third hierarchy, fourth hierarchy, and the fifth hierarchy. So at fifth hierarchy a condition is getting true and you are going to stop over there. So a fifth hierarchy will return its output to the fourth hierarchy. So you will go level up in this particular case. The fourth hierarchy will be going to give the output to the third hierarchy. The third hierarchy will be giving the output to the second hierarchy, and the second hierarchy will be giving the output to the first hierarchy. The first hierarchy means your main function, so actual output. So in this particular way, your recursion function is going to work. So you are calling that particular function inside the function. Now we will see one example. This particular example is related to the calculation of the factorial of a number. So what is the meaning of factorial? So basically a factorial is calculated as, suppose if you want to calculate a factorial of 5. So it is calculated as 5 into 4 into 3 into 2 into 1. So you are supposed to take all the numbers which are lesser than that particular number up to 1. Suppose if you want to calculate a factorial of 12. So you will go for from 12 into 11 into 10, means you will go up to 1, and whatever the product is, that will be displayed as the output. Now in this particular example, you can see the 5 factorial is exactly equal to 120 because all the product is giving a value equal to 120. Similarly, if you want to calculate a factorial of 6, then that will be 120 into 6, that is related to 720. So here we will see this, but this is the actual logic of this particular program, and you can see we can call this particular function using a recursion. We can solve it normally also, but also we can define this particular function as the recursion. So here you can see, here we are defining this particular basic recursive factorial function, and here you are going to give a accumulator function, so that your output will be stored in some accumulator, and in that particular space you have to give the n, and basically here you can see that particular number will be multiplied. So here you can see the actual output. Okay, now in this particular function, what you are doing here, you are defining one more function, and in this particular function you are taking two values. Okay, and these two particular values will be multiplied with each other. Now there is one question, why we are making this particular function as a complex. Making function means you are separating the task. Now here in this particular method, you are having only a single task. Okay, and in that particular single task, you will be having a single statement. But in this particular example, you are having two tasks. One is normal your function, and the second one is called as the accumulator function. So in this particular part, you will be go on executing, and then that particular output will be given. Now here we will understand this particular line, basic recursive function. If you understand the basic recursive function, you are able to understand the tail recursive function also. So how these particular things are going on? So here you can see, here we have to see this particular condition. Means if n is equal to 0, then it will return 1. Else it will return n into factorial of n minus 1. So here you are calling this particular function again. It means that this is a recursive function. You have defined the same function and you are calling this particular function with another value, and therefore it is called as the calling by method of the recursion. So now we will see the execution. Suppose if the value of n is equal to 5. Okay, see, the result is simple. So we will just note down that particular result. So it will be input is written in the terms of n, and if n is equal to 0, that is called as a terminating condition. That is called as a terminating condition, and for a termination it will return 1. Okay, so it will terminate your program. It is not going to call your function again, and instead of not calling the function, it will be passing a value 1, or it will be calling that particular function. So call the function again with a value n minus 1. So you have to reduce that particular number by 1, and again you are going to call that particular number. So we will follow that particular step. So there are only two steps. One is called as the n is equal to 0, and that is called the terminating condition. And as the output of the terminating condition, it will return 1. Otherwise, it is going to call the function again with a new value, and the new value is reduced by 1 because you have written the formula that is n is equal to 1. Now let us start the execution of this particular program. So we will call the iteration number 1, where a function will be called with 5 because the value of n is equal to 5. As function of 5, it means that the value of n is equal to 5. So we will see whether we can terminate this particular thing or not. So for a termination, we require n is equal to 0, but now n is equal to 5. So it is not going to terminate. So what will happen? It will call function n, that is 5 minus 1. Okay, the value of n is equal to 5, right? So 5 minus 1, that is 4. So whenever you are calling this particular function, now it is a new context. This is a one hierarchy, this is the first hierarchy, this is your second hierarchy, but your second hierarchy will be the called as the second context. And in this particular context, n will be considered as a 4 because you are taking 4 as the parameter. So what will be the value of n? N is equal to, so for function 4, n is equal to 4, right? So again we will see whether it is going to follow any kind of terminating condition, yes or no. No, because n is not equal to 0. So what it will do? It will again call a function that is n minus 1. So it will, now the value of n is equal to 1. Therefore it will call 4 minus 1. Okay, the value of 4 minus 1 is 3, right? So what will happen? Now you are going to call, this is a third hierarchy. The first hierarchy, function of 5, second hierarchy, function of 4, and the third hierarchy, function of 3. Though it is hierarchy, still it is calling a function. And it is, as it is calling a function, it will be called as a new context. So function of 3, and in this particular case, the value of n is equal to 3. Okay, now again I will see whether it is going to follow any kind of terminating condition or not. But again I will find n is not equal to 0. It means that we cannot go to the terminating condition. So again we have to call a function to n, that is 3 minus 1. And what is the value of 3 minus 1? It is 2. Okay, so this is your fourth hierarchy, right? Now again we will define, go into the fourth hierarchy. So here function 2, let us follow the same rule. As it is hierarchy, still it is going to have a new context. So n is equal to 2. And now what I will do? Then what I will do? I will just try to n is equal to 2. Therefore n is not equal to 0, right? So I'm not going into the terminating condition. So what I will do? I will simply call function n minus 1. Value of n is equal to 2 minus 1. So 2 minus 1, it will be 1. So again there is a new context. So I'm going into the first, second, third, fourth, and fifth hierarchy now. So let me call it differently. Function 1, value of n is equal to 1. So value of n is equal to 1 means it's not equal to 0. So I cannot go to the terminating condition. So I will call function 1 minus 1. Okay, that means value is 0. Again you are calling a function. So it will be sixth hierarchy. So let us go into the new context. Function of 0, right? So now you can see the function of 0 equals, function of 0 means n is equal to 0. Now I am going to get a terminating condition. So finally, as n is equal to 0, I am not going to call any other function. Okay, I am not going to call any other function. So what will be the value of function 0? The value of function 0 is equal to 1. Okay, because I'm getting the terminating condition by returning that particular value. So function 0 will be having a value equal to 1. But not only calling that particular function, I'm also having one relation that is called as the n into multiplication. Okay, so to remove the complexity, I didn't use that. So again I will go back. So it will be called 5 into 4 because n into function n minus 1. It will be 4 into 3. It will be 3 into something 2. Then here it will be 2 into something 1, and here it will be 1 into something function of 0. Okay, just we are following this particular formula. We done with this particular formula, just call, but we forget to write this particular value, therefore we wrote. Okay, just I will explain this particular thing again. Function phi u, n is equal to phi u, so n minus n into function n minus 1. So n phi u into function n minus 1, that is phi minus 1, 4. So this particular thing is going to be repeated. Means when n is equal to 4, it will call 4 into function of 3. If n is equal to 3, it will call the n into function of n minus 1, that is 3 into function of 2, that is 2 into function of 1, 1 into function of 0, and so on. So at function of 0, I am getting a terminating condition, so the value of function of 0 will be 1. So I will write this down over there. As the value of function of 0 is 1, so that will be replaced over here because it will return 1. So here I am returning this particular value. So what will be the value of function 1? That is called 1 into 1. That is 1. So value of function 1 is again 1. So that will be written over here. Okay. So you are just going to return all the values again and again to the upper level. So this will be 1. Now what is the value of function of 2? That is 2 into 1. That is exactly equal to 2. So what is the value of function 2? That is 2. Then function of 3, 3 into 2, that is 6. Okay, so the value of function of 3 is equal to 6. So that will be written over here. What will be the value of function of 4? That is 4 into 6, that is exactly equal to 24. So that will be written over here. And finally, the value of function phi is equal to 120. That is called as the factorial of a given number. So what is going to happen? We are going to create the hierarchy, and then we are going to solve the hierarchy from the inner loop. So the outer loop is f function phi u, and the inner loop will be function 0. So first function 0 will be evaluated, then function 1 will be evaluated, then function 2 will be evaluated, then function 3 will be evaluated, then function 4 will be evaluated, and finally you will be going for function 5, and that will be your output. So here you are going up to the down hierarchy, then for getting output you are going level up hierarchy, so that it will return the respective output. So in this particular way you have to use a recursive function. Now here a terminating condition is required. If you don't have the terminating condition, what will happen? You will go into the infinite loop. So it will become 0 minus 1, so that will be minus 1, again minus 1, that is minus 2, and it will go on. So function minus 1, function minus 2, and so on. So there should be a terminating condition which will stop over here. Similarly, here we are going to work with the accumulator, so that these particular things will be managed by this particular term, so that n in the accumulator will be having a value. Now what is the job of this particular accumulator? It is going to store the previous value. Now initially it will be 1, later on it will go on storing that particular value. We cannot store it 0. If we store it 0, all output will become 0. So it will go in this particular way. So here whenever you are returning the value, it will return the values accordingly. So first it will return 1, then again it will return 1, then 2, then 6, then 24, and finally 120. So in this particular way, a recursion function is going to work. So these are several functions where we are calling by the name, calling by the references, calling by the addresses over here. Just they are going to follow a Java methods. Okay, means if you are calling, it is just like calling those particular things along with the help of addresses or the references. That is called as the references. But if you are calling it by the value, passing it a particular value, that will be called as the call by value. So nothing big thing over here. Now this is one where we can write a cases. Okay, so here you can see the same function is given and its return type is given as a unit. Basically here you can see, because it is going to return the different things, therefore it is going to keep the return data type as a unit, and basically we will follow this particular part. So you can see how the cases are written. So based on that particular, it means if a particular value is true, so it will go into that particular column. Means for example, I will be writing the cases for 1, 2, 3, 4, and it will go on A. If value of A is 2, then it will go to the second column because it is going to work for the case 2. If value is 3, then it will go to the third column, and so on. Just like a normal pattern matching, it's going to work. Similarly, we can call a list as a parameter. Here you can see the example. Basically, we are not supposed to write down any kind of complex functions over there. Just we are supposed to write down the simple programs. Therefore, those we are not need not required to study. I'm not going to focus on this. Those we require to study, I will only focus on this so that it will reduce the confusion. Now, what is the advantage of the functional programming in the Scala? So that these are particular properties like lazy evaluation, eager evaluation, currying, concurrency, and the closures. Now you must be knowing the things about the concurrency, which is related to the thread concept. Where suppose if there are two processes, and if you are going to work with the two processes, what will happen if the two are independent processes? In that particular case, those two processes will try to match their performance with each other. So they will just try to execute a program, and there will be a certain kind of race condition between of them. So this particular part should be avoided in this particular case. That is called as a concurrency. So multiple processes are going to execute the task in a single time, and therefore there will be a race condition in this particular part. The main execution part, which is called as a lazy evaluation and the eager evaluation, that we will see. So the name itself suggests a lazy, which is going to collect all the values, all the variables, all the labels first, and later on it will go on the executing. Eager evaluation, whenever you are getting the executable statement, you are executing that particular statement. So here you can see mostly the dynamicity is provided in eager evaluation. Even in lazy evaluation, you can provide a dynamicity. Basically, Scala is basically it is just like a lazy evaluation, but it is also you can convert that particular lazy evaluation by eager evaluation. Just like Java, which what you are doing, you are writing a main function. Okay, so in Java, you are writing a main function, and in that particular main function, you are taking a parameter which is a command line arguments. Or you are having a buffer input stream reader class. So you can take a runtime input use of, if you want to take the runtime input from the command prompt, you can take it from those particular variables or those particular parameters. Or there is another way that you can define a class, and from that particular class you can take the input. So in this particular way, you are converting the lazy evaluation to the eager evaluation. Then the question is why we are calling it as a lazy evaluation? Because we are executing the class file. And to create a class file, we have to compile our program. So we require a compiler to run the program. So it will create, it will just work with all the labels, variables, constants, and all those particular things. And later on, it will be allowed for the sake of the execution. Therefore, it is called as a lazy evaluation. Just like in Java, we are compiling our program with Java C, whereas in Scala, we are compiling a program a Scala C. And for Java, we are running a program with Java. In Scala, we are running a program with a Scala. So basically, we are going to follow the same pattern, but the difference is the creating the object. In Java, you are going to work class as the data type. You can use a class as the data type, where you can have their own methods, their own variables, their own values, etc. Here we are going to work the classes as the entity, and that is a big difference between the Java and the Scala. So just a way of the implementation, and as it is the entity, as it is the entity, therefore we are not going to means here we are not required to write down any kind of punctuation marks over there. So here you can see the work of the lazy evaluation as well as the eager evaluation. Basically, both are supposed to be called as the programming structures, but mostly we prefer the lazy evaluation because it is going to collect all the variable symbols, and for the speedy execution we are going to use the eager evaluation. That particular thing is considered over here. Now the next method is occurring. So here what you are going to do, you are trying to define a multiple methods or define a method that may have a multiple parameters. And this particular method, when a method is called with a fewer number of parameter list, then this will yield a function taking the missing parameter list as its an argument. For example, you have defined a function and you have defined it with two parameters. That is a parameter 1 and the parameter 2. But while calling, you are calling it with a single parameter. So what will happen? For this particular purpose, you have to define a default value for those particular parameters. So it will go on working with those particular default value. Now, for example, we can have this particular example. Let us have this particular function def function 2, and here you are passing a value param, data type is integer, and the value is 20, comma param 1 and param 2. Param 2, the value is integer and the 30. Fine. So you have defined this particular function. So the default value for the parameter 1 is 20 and the default value for parameter 2 is 30. Now I will call the functions in a different way. For a function 2, and here I will be passing 40 and 50. So what will happen? Now here this function will be called with the value 40 and 50. So the value for the parameter 1 will be 40 and the value for parameter 2 will be 50. Suppose if I am calling this particular function as function 2, 10. So what will happen? The value for parameter 1 will be 10, but the value for parameter 2 will be 30. Because as I have not defined a value for parameter 2, or I have not taken the value for parameter 2, so it will go for taking a default value. Suppose if I want to take the first value, then I will just use a wildcard. Because in Scala, we are using a wildcard using underscore. So that here the parameter 1 will be 20 and the parameter 2 will be 10. So here in this particular way it's called as the currying. So what is the use of currying? Here you are calling a method with a fewer number of parameter list, and therefore it will go with a default values as the argument. Next, the closures. So what is the meaning of closure? The closure is one whose return value depends on the value on one or more variables declared outside of this particular function. For example, you have defined one method related to the voting age. If yes, then it will return a value true, otherwise it will return a value false. So here you can see we have created the function and taking one parameter age as the input, and this particular value is defined already. So here you can see the age is the parameter, but a value which we are using for the comparison is defined previously. Like here you can see if age is greater than or equal to voting age, then it will return a true, otherwise it will be returning a false. So that this particular voting age is the 18, so that particular value will be compared with the 18. If this is a greater than or equal to 18, then it will return true, otherwise it will return a false. So here this particular function is dependent on the value which is defined previously. So here you can see the function is called is voting age 16, and as the 16 is less than 18, therefore it is returning the false. If you have written 19 or 18, then it will return a value equal to true. Then the concurrency, so basically we have three options. One is called as the actor model, second is called as the thread, and the third one is exactly the Apache Spark. So here you can see this particular model is defined in 1998. So that just like a basic language where you are supposed to define a synchronization blocks. Just like allocating the resources, allocating the appropriate resources, and once those particular resources are allocated, you can just find out a respective things. Means, for example, if you are having a five resources, I will name the resources as R1, R2, R3, R4, and R5. And if you are having a five processes, I'll be calling it as a P1, P2, P3, P4, and P5. So if P1 is taking a process resource R1, so it will lock that particular resource. We can create a circular wait condition so that a P1 will wait for the resource which is taken by the P2, and P2 will wait for the resource which is taken by the P1. So that it will call as a circular wait and it will create a deadlock. So these particular things means normally for basic concepts of OS is going to be dependent on these particular states. So what is the actor here? Actor is an object that receives the message. They are having a mailboxes for queue of incoming messages so that they can communicate with the message, and the message is the message communication is done in an asynchronous way, so that it will return a particular message. I mean, sending a message to an actor, so they are going to immediately return that particular message, or they are not going to process any kind of message over this. Next one is related to the object-oriented programming in the Scala. So what we are going to see, we have to see the classes, objects, threads, case conditions, and the exceptions. Now these are taken from this particular slides. We require to work with the classes, objects, and the exceptions. Means if we are having certain kind of exception, means whenever we will run the program, we will see the respective output at that particular time. We need to go with means if there is any kind of logical errors, then we need to go with the exception. For example, if you are going with a division operation, and if you are trying to divide a number by 0, right? So it's not a wrong. Means if you go by a syntactical way, it is not a wrong thing. Means you can divide any number by anything, but it will not return any kind of output. It is a logical mistake that you cannot divide any number by the 0. That is the rule of the mathematics. And as you try to divide, the output may be infinity. So it will generate the exception, because in computer we do not have any parameter or any concept to store the infinity value, and this particular part will be called as the exceptions. So here you can see how the classes and these particular things are defined. So I told you we are defining the classes as the objects. So the class person, and here you are taking their parameters. So this particular person is the entity, and this particular entity will be having two values. The first value will be name, and the second value will be age. So you can define the entity just like creating the databases. You can define n number of entities over there, and these particular entities will be working in this particular way. So the objects, so one normally if you call as a Java, they are a way to access the elements because they follow a rule of object-oriented programming. What are the rules? Like encapsulation, inheritance, and the polymorphism. So in the case of encapsulation, you are binding your data. In the case of inheritance, you are using the properties of inheriting the properties of another class. And in polymorphism, you are defining the abstractions, like you are defining once and you are using it whenever required. So these particular things are also going to be done by the Scala, as it is also going to follow the object-oriented programming. So this is a way that of writing a program. So here you can say a default name is nobody, and you have defined one entity. The entity is created, and is taking two values. One is a string, and the second one is the age. As we are calling the function without any name, so it will be a blank, or it will be go into the default value, that is a nobody. So when we run a actual program, you will come to know about all those particular things. So these are the abstract classes where you are defining the classes and then you are using. You can see different kinds of cases are given along with the passing their number of parameters. The exception is also given. Now here you can see that particular example. Now here what we are doing, we are taking this string as the input and we are trying to perform a mathematical operation on a string which is not possible. Okay, you can do a concatenation on digits. Means for example, if you want to concatenate, means this is a string operation. If you want to concatenate 5 and 6, so it will become a 56. Okay, if you want to add two numbers, then it will become a 11. But you cannot add two numbers, two characters or two string. So what we are doing over here? Here we are defining a main class. In this particular main class, we have defined a main function. Now it is much more similar to a public static void main. So as we are having a public static void main in a Java, we are having def main in a Scala. So it is your starting point of your program. So it should, your each and every program, if it is not a method or if it is not an entity, you have to create a main function. You have to write a main function. And a program will be saved with an object name which is having that particular main function. So for example, if you are having two objects, the object A and object B, and if you are writing a main function in object B, then the name of that particular program will be b.scala. So b.scala means B is the name of the program and the Scala is the extension. It is much more similar to the Java. And what we do, a class in which we are having a main function, we use the name of that particular class for storing a program. And we use the extension .java for storing that particular program over there. Similarly, we are going to follow the same format where you are going to save with the name of the object which will be having the main method, and the extension of your program will be Scala. And then you can write down the program. Now here a mapping is done which is used to convert that particular string. So here you can see the integer is taken and you have tried to calculate a sum. Now here you can see we are trying to convert the string into the integer, but the string should be also integer. Means here you can see we are taking this particular value as a command prompt from the command prompt. So you can pass any value. Suppose if you are passing a 6, definitely it will take 6 as a string, because from command line you can take a variables which will be strictly in the format of string. So 6 will be in a string format or in a textual format. Now what is your job? You need to convert that particular program. Now here you can see what we are going to do in this particular part. We have to convert this particular string for the processing. So for example, if you are taking a 6 is the digit, so it will get converted into the integer. But what if I take A? Definitely A is not an integer, so A will not be taken as the input and it will generate the number format exception, as your input is not in a number formatting. Therefore, if you are taking an actual string, it will generate the exception, it will generate the logical error because you are not able to convert your program or you convert your variable into the integer. But if you are taking it from in the digit format, then it will get converted into the integer, and then you can use or you can convert and you can perform a mathematical operation on that particular part. So this is the use of exception. So if you made any mistake while taking the input. And if you are not able to find out it as a syntactical error, then what is your best option? Go for the exception, and from that particular exception, you can save from coming out your respective program. Trait it's there, so it's just like going to work with a simple interface like structure. As we are having an interface in Java, we are having trait, so that we will be using in the same manner. So a trait will be having, it is a group of variables, or it is just like a group of functions. So you can just use those particular functions into the classes, so that these particular classes will be using those particular functions. Now for example, let us take a trait as a information. You will be having name, age and marks, and you are creating a student class. And if you are to use those particular parameters, simply you can extend with a define a trait over there. So that's done. Then you can just go on increasing those particular traits. Now here one more thing, that you can mix those particular traits with each other. In while doing with the Java, it's not possible. Means if you go on the multi-level inheritance, it's not possible. Multiple inheritance is possible. Means you can inherit two classes at the same time. But here we can just extend those particular interfaces over there. So here you can see we are having a multiple inheritance. Okay, now these are the steps that we should follow. So first you have to install the JDK, download and install the JDK. Then you have to download the Scala. Then we have to create the environment variable, and then you have to check whether the Scala is installed or not. Then you can see the actual execution. So this is the theoretical part of the Scala. So now we will shift to the practical. We will see at least see the installation, and we will try to run one program. So do you have any query in the theoretical section?
No, sir.
Fine. I hope you have understood the logic also, because it is also important. Now let us see how to install this particular thing. Now I will just edit this particular part. So what are the steps? First, install the Java. Second, install the Scala. Third, set the environment variables. And then test Scala. Okay, so what I will do, I will go to the Google and I will download the respective setup. You also do the same thing. Then we will try a few commands and we will see one program. Later on you can install that particular thing, and then we will go into more programs. So let us see. First, go to the Google, and here you can type JDK 1.8 download. Okay, you can go to the JDK. You have to create the Oracle account. If you have, then it's okay. If you don't have, it is a free of cost. You can just create and you can download the respective part. Now here you can see we have to download the JDK. Okay, don't go for the server installation or except anything else. So you can see it's you can see the different versions are over there, but we are not interested on those particular versions. So immediately we will see it is the first part, that is the Java SE development kit. And in this particular part, go to the Windows if you are using the Windows operating system. If you are using a 32-bit operating system, then you can download the second last option. If you are using a 64, then you can download the last option as well as second last option. So just click on that. It will download your setup. It is almost around 211.58 MB. So it will take approximately 2 to 3 minutes if you have good quality internet. Once it is done, you have to install. Okay, do not go for the default path. Set it as your own convenience. So here you can see I have done the installation at the C colon. So the program files, and here I have selected this particular folder so that you can see my Java is installed over here. Just I am searching that particular part. Okay, here you can see I have installed the Java, and you can see two folders. Okay, now you require these two things. Means once you installed, you have to see whether you got two folders or not. Many times we get only JDK, or many times we get only runtime environment. JDK is Java Development Kit, whereas JRE is a Java runtime environment, and both are required. Okay, especially JRE is required because it's going to work on the concept of the JVM. Inside JDK, you will get these kinds of 4 folders. The name of the folders are bin, include, JRE and lib. Go to the bin and you will see number of batch files or the application file. It should be over there. Okay, then what you are supposed to do, you have to copy this particular part up to bin, copy this particular part and go to the environment variable. Here you need to click edit the system environment variables. Go to the environment variable. There are 2 sections. One is called as user variable and the second one is called as system variable. Go for the system variable. Click on path. There are several variables. You have to select a path, double click over there, create a new and copy. Here you will get a prompt for entering that particular text and just paste your text over here. I'm just cancelling it because I have done this particular thing already. So here you are done with a setting environment for the Java. Now second part, you have to install the Scala. So I will go to the Google again, type Scala, version is 2.13 something, and then you can see the second option is over there, that is all available versions. Click over there. So here you can see the Scala 2.13.0. Click over there and then you have to see the MSI file. Here you can see the MSI file is over there. So what you can do, you can just click on that particular MSI. Go to the Google, type Scala 2.13, go to the all available version and then click on this particular 2.13 MSI. It is a MSI installer, so that if you double click on that particular thing, just again set a installation path as per your convenience, because you need to remember that particular thing to set the environment variable. Therefore, you have to just go, you cannot go with the default path. So here you are going to install this particular path over here. And then you can see I have installed this particular Scala somewhere here. Okay, here just let me search. Program files, no. C. Okay, here you can see my installation is done. So again, you will be having 4 folders. You have to ensure whether you are done with 4 folders or not. In that, you are having bin, and you need to just copy that particular path and set it to the environment variable. The variable name is path. So again, create a new, copy and save it. So here you can see we are done with a Scala setting environment for the Scala. So here you can see I have done a path setting over there. Similarly, I have stored the path for the Java also. So once it is done, you can go to the command prompt and you have to check the installation. So I will open the command prompt You need not to go with the administrator setting. If you are not going with the administrator setting, that is also okay. And type Scala, that is SCALA. Type Scala and press enter. If you found a command, it means that you have installed a Scala successfully. So here you can see a message is coming. Welcome to Scala 2.13.12. The JVM version is given, that is 1.8.0 underscore 202 something, and it's also going to give me a setup format, that is a 64-bit, because I have installed a 64-bit. Therefore, I'm using that particular format over here. Now I will execute few commands like var, define a variable that we have seen in the last lecture. For defining a variable, we use a keyword var, then its variable name, then colon, and then their data type, that is int, and then its respective value, that is 45. So I will just enter. So here you can see the value is given. The value a is equal to 45. So I can see the value. So here you are getting some kind of resource 0 ID, and the value is giving as a 45. You can go with any other data type also, that is var b. I will use double equals 45.23. It's taking. If I try to display, you can see the resource ID is increased. Now I receive 1, and the value I'm getting that particular value. So if you are able to execute these particular statements, or if you are able to see the respective editor, it means that you have successfully installed your Scala. Fine. Now let us try to write one simple program, one simple hello world program over there. Okay, we can use those two particular variables for the addition also, and that can be also displayed over there. Just you have to type the mathematical operation, that is a plus b. So that will go. Now let us open one notepad. Let us start with writing a simple program. Just a minute. So here, first I will write a program in Java. Simple. We have to create a class, then its class name, hello world. Then this is a scope of that particular class. It means that whatever the variables are written in that particular curly brackets will be under this particular class. And now I will define a main function, public static void main. Then okay, for installation you have to go to the Google, and then download JDK 1.8. You need to have an Oracle account, and then you can just download a respective file. If you are working with 32-bit, you can download a second last option. If you are working with 64-bit, you can download the last option. Okay, then just select next. Means if you run, you will get one prompt, and just you have to click next, and just you need to set a path of your own convenience. Once it is installed, you can see your installation is done in this particular part. So program files. Okay, here you can see you're having this particular folder, that is Java, and you will be getting these two particular folders after the installation. Now you have to set a class path. So you need to go into the bin folder. Inside JDK 1.8.0 underscore 202, you are having a bin folder, and inside bin folder you will be having a several number of batch files. So you can just copy that particular path, go to the environment variable, click on the environment variable, double click on the path, click on new, and just paste that particular path over here, click on OK, and now your Java installation is done. It's all about setting the class path, nothing else. For several practicals, like from practical number 3, you need not to go for that kind of installation. You need to go with the installation only for the practical number 2. So definitely we will be having these particular parts in the offline. So if you are not able to understand, no problem. Just download the setup, try to install, and try to set the environment variable. If you get any problem, you can send me the screenshot so I can help you on your we can just share that particular thing on WhatsApp. Got it? Fine. Let us move ahead a little bit. So here we have to write a main function, string args, that is the argument. And here I'm just printing the string, a print message, system.println hello world. So this is a way of writing a Java program. Okay, now we will use the same pattern. Instead of class, we will use the object. O is the small object, hello world. Here same, we will be having a main function, but we are not supposed to return anything. We are not supposed to give any kind of semicolon. We are free from those particular syntax glitches. So that just define def main and then args, same as you are defining this particular variable. You have to define its data type. It should be array of string. Similar pattern we are using. This is also array of string, and here you are defining it array of string. Then open the curly bracket and just write down println for printing the statement, that is hello world, and just complete your brackets. We are defining the scope of the object as well as the scope of the main program. Now what I will do, I will just remove the Java part. Let us save this particular program. Save. I will save this particular program over here, new folder, Scala. And here you have to write a name of the object class in which you have written the main function. I have written main function in hello world dot Scala, all files. So I will be used save. So your program is saved. Remember, you have to write the name of the file dot Scala and select all files. If you try to save it with a text document, it will take two extensions like hello world.scala.text, and it will not run your program. So you have to remember the thing that your save as type will be all. Now go to the command prompt. Go where you have stored your program. And now for first we have to compile the program. So for compilation, you have to run Scala C and then the name of the program, that is hello world.scala. Enter, check for the errors. You will get one warning. You are not going to get any kind of the error over there. See, you are getting the warning because you are trying to execute it with the JVM, and then you can run your program with the Scala, that is hello world Scala and the name of the file. While running the program, you cannot give the extension because here I will just open that particular folder. So here you can see this is my file and a class file is created. So we are supposed to execute that particular class file. Therefore, you need not to write any kind of extension over here. So for execution, use Scala, the name of the file, and press enter. So it will display the hello world. So I repeat, you have to write object, the name of the class, it can be anything, hello world, define the main function, write down the command line parameters, give the type of the parameter, and here I'm just printing a statement. Now in this particular case, I'm using a main function, therefore it is not written in the form of the statements. And also I have not given any kind of the return type as I'm doing in the Java. Also I have not used any part of the semicolon or the colon. Means I'm not giving any kind of the punctuation mark. And that is the advantage of the Scala, because a Scala itself, they are having their own existence, but they execute on the JVM. Therefore, we have to compile and run the respective program. This is the first program, that is the hello world. Fine. So any query in this particular program?
So there's lots of background noise.
Sorry.
Sir,
Yes.
hello.
Yes, please repeat your query.
I think someone else asked it. Sir, I wanted to ask, in the syllabus we have Scala and Python.
Hmm.
So you taught us Java, right? Installation and Scala.
Yes, the Python will be taken during the practicals. We are not running any program in the Scala during the practicals, therefore I'm taking it in the theoretical lectures. So when we run for the practicals, we will see the Python syntaxes, and as of now we will complete it with the Scala.
Okay, sir.
Okay, fine. I think we will stop over here. If you are having any kind of the query, please ask.
सर ये कोड एग्जाम में भी लिखना पड़ेगा?
हाँ, आएगा तो लिखना पड़ेगा.
तो सर एक बार थोड़ा एग्जांपल बताएंगे कि मतलब किस तरह से क्वेश्चन
एग्जाम में सिंपल पढ़ाएंगे.
लाइक
मीन्स वॉट एवर द टेकन इनटू द क्लासरूम वही आएगा. So any other queries?
So how are you going to take the internals?
Let us complete the unit 1. Then we will take the examination from the Google form. Means in last semester year, I have taken the examination through Google form. I will ask to Josna ma'am about it, and we will follow the rules.
Sir, how will you conduct practicals?
First, we will complete the practicals in online mode. Then we will meet for the offline session, because the offline sessions are required. We cannot conduct all the practicals in online mode. So once we complete this particular part, in the month of October, we will meet for 2 days. The practicals are so simple, so it may get completed in 3 to 4 hours. So possibly 2 meetings are enough for this.
Okay, sir.
Okay. So any other queries? Fine. If you don't have any kind of the queries, let's end the meeting. Thank you.
Sir, can you upload the notes?
Yes, I will upload the today's files.
Okay, sir. Thank you.
Sir, will you be uploading
Sir?
the Hello World program which we just now?
Yes, I will be uploading
Perfect.
that particular Hello World file also.
Okay.
In fact, I will upload that file only. Otherwise, if I upload all the programs, if you may get confused.
Sir,
So
attendance.
I will just share this particular file.
So how about assignments?
I will share it on the Google Classroom.
Sir, you have taken attendance or?
Yes, I'm doing the same thing. Just taking the screenshot.
Okay. Yeah, sure.